Welcome to MIPI DevCon 2020. Thanks for joining. We're glad to have you with us today. Feel free to engage with the presenters and attendees by using the engagement tools at the footer of your screen. Click Q&A to engage with presenters and group chat to communicate with the attendees. You can simply minimize or maximize each of these icons with one click. To see the agenda, sessions, and demos, click on the Call to Action icon. Enjoy the conference.
Welcome everyone to the MIPI Alliance 2020 Virtual Developers Conference. Teledyne LeCroy would like to present the Envision X84 Protocol Analyzer and Traffic Generator for CFI, DFI, and CSI-2, DSI-2. Envision X84 is a protocol analyzer and traffic generator for C and DFI and CSI, DSI, all in a single hardware platform. The X84 can record or generate up to 4 lanes of DFI and up to 3 trios of CFI at a maximum capture rate of 2.5 gigabits per second. The Envision X84 in analyzer mode can record all CSI and DSI events. It has the ability to do capture and image playback. It offers video analysis, timing diagrams, as well as a conformance test suite for both CSI and DSI. In generator mode, the Envision X84 can send single packets of CSI, a sequence of packets, or by setting it in video mode, the Envision X84 can generate full frames based on a user-defined image. The generator gives you control of the resolution and the frame timing parameters. With the introduction of advanced driver assist systems in the automobile, car manufacturers are relying heavily on different types of sensors. Radar, LiDAR, camera, and image sensors all use the MIPI CSI-2 protocol. With improvements in infotainment and the cockpit as a cocoon, cameras and displays are being added to the automobile at an increasing rate. The MIPI CSI and DSI specifications are mature, well-proven, and simple to use. Today, as the automotive industry looks to move image data long distances within the automobile, the image sensors transmit pixels via the CSI protocol over DFI or CFI. These signals are then handed off to a SerDes and bridged to a long-distance transport. The pixels are then deserialized at the image processor or the SoC for processing. These translations can cause numerous issues. This is where the Envision X84 protocol analyzer comes into play. As the images of what is being transmitted do not match with what is being received, a protocol analyzer can help determine where the point of failure is occurring. As with cameras and image sensors, the automotive industry is implementing more and more displays in the cockpit. For infotainment, in-dash displays, and the display as a side view mirror. The Envision X84 can also capture, analyze, and display DSI traffic. As the SoC is transmitting traffic to a display module, the X84 can validate that the images being generated are what should be seen. As every display module has different modes and resolutions, testing the SoC or display driver against many displays can be cost prohibitive. Where using the X84 can capture any resolution or frame rate allows for testing of the implementations ahead of time. So in today's demo, we'll show the Envision X84 generating MIPI CSI-2 traffic and capturing the same traffic with the second Envision X84. The Envision X84 can generate single packets or a sequence of packets. In creating a sequence, the user can send packets in the expected order or can create out-of-order packets to determine how the device under test behaves. To generate a packet, simply click or double-click on the packet desired. You can also drag and drop to create your sequence. In this case, we're going to generate short packet 1 and short packet 2, followed by a frame start, followed by a line start, a frame end, a line end, and a blanking packet. Now obviously, these packets are out of order. How would the device under test react to seeing packets in this sequence? The Envision X84 can also generate full image frames. When used in video mode, the user defines the packet format, the frame timing, the resolution, and either a .bmp or a .bin image. The X84 will generate all lower level traffic automatically to generate the frame. As in packet mode, the user can create a sequence of frames to generate multiple frames one after the other. The user can also set up a counter so a frame is repeated. In the interest of time, I'm going to load a previously created sequence. We're going to select all of the packets, all of the frames to be generated, and we're going to select one frame to be repeated 3 times. We'll now begin generating these frames in a continuous loop. As we begin transmitting our frame sequence in a continuous loop, we can now configure the second Envision X84 to capture the traffic. In the Capture Setup tab, the user defines the desired packet structure to start capture and how much traffic to capture before starting. The user can also use the external trigger in to start or stop the capture. The user can use up to 4 different user-defined decodes to also start, stop, or trigger an external piece of equipment. For this demo, we will look for the first frame start and capture until we see 11 frame ends. This should allow us to capture 11 full frames of traffic. Once we start capturing, the Envision looks for the first frame start and captures and fills its 4 gigabytes of memory until it sees the proper number of frame ends. At this point, it loads all of the packet and events captured into the Events tab. The user can look at all events or filter to the particular event or packets of interest. We supply several default filters, but the user can also define their own event filter. Looking simply at the long packets, we can see the precision timestamp, the delta time from the previous packet displayed, the data type, the virtual channel, the data link, and the decoding of the packet information. Double-clicking on a packet brings up the actual data payload of the packet, in this case the actual pixels. This data payload can be saved or appended to an external file for offline analysis. Moving over to the Video tab, the Envision X84 can play back the captured images. During the playback, it will display the detected image format, the resolution, and the RAW format. The user can also choose to compare the captured frame with a golden image. By selecting Compare Frames and getting the video data, the captured image will be compared with the golden image, and the number of pixel errors will be displayed beside the frame number. If the View Differences button is selected, those pixels in error from the golden image will also be displayed as a black pixel. Once you've played back the captured image, you can do a video analysis. The Video Analysis tab reads the event file and gives a summary analysis of all the frames. It shows how the frame looks relative to transmission. The user can confirm line starts, frame blanking, frame starts and ends, line ends, and line blanking. The Envision X84 will distinguish line blanking done with low power states or with blanking packets. The analysis also shows the frame rate, the resolution, the average amount of time spent in blanking periods, as well as payload size and errors. Along with video analysis, the Envision X84 allows for more detailed timing analysis. In the Timing Analysis tab, we can select all our events and then measure frame start to frame end, or better yet, frame end to frame start. This will show how much time was occurring between frames. We can also look at line end to line start to show us the amount of time spent during line blanking. Once you've selected your parameters, select Analyze Event Timing. Here you'll see your average time, your minimum time, and your maximum time based on the number of occurrences of the parameters you were looking for. Last but not least, the Envision X84 supports the MIPI CSI-2 and MIPI DSI-2 conformance test suite. When you process the events, the protocol events are compared to the MIPI conformance test specification and given a pass, green check, a fail, red check, or a warning, yellow check. The event count section of the display informs of each event type and the number of occurrences captured. The event file portion shows the event files being analyzed and a summary of the conformance tests and their results. Double-clicking on any of the test results will highlight the specific test, show the result, and give an explanation of the pass, fail, or warning in the comments section. This concludes our demonstration for today. If you have any questions, please see us in our demo area for more information. or contact us at protocolsales@teledynelecroy.com.